We are the Zero Waste Assistants with the UW-Madison Office of Sustainability. Today we're here to talk to you about our pilot project with Busch Systems. During the 2021-2022 academic year, we teamed up with Busch Systems to help test a smart bin project. We did this to revamp our waste and recycling program here at Ingraham Hall.
Ingraham Hall is a centrally located building on the UW-Madison campus. The hall is a mixed-use academic building fit with office spaces, a Badger Market, and lecture halls.
Here are examples of our old bin stations. Originally, recyclables were collected in a dual stream method. One stream was for commingled items such as cans, glass, and plastics. The other stream consisted of mixed paper. These stations were disorganized with non-uniform bins and signage, making disposing of items confusing. They were overflowing and unsanitary, which represented an issue related to waste management and recycling.
Here's an example of our new bins. This project switched to a single-stream recycling system where both streams could be combined into one. By using new bins with distinct colors and icons, we hoped that this would make recycling more logical for students and staff. We also hope that this will make the custodian's job easier. These stations were dispersed throughout the 5 levels of the building, giving us 16 stations, which consisted of 17 waste bins and 25 mixed recycling bins. In total, we maintained 42 bins.
Come check out our stations!
This is the Busch Systems Resource Center, where we can see all of our bin stations, their hub battery life, internet signal, percentage of fullness, and their current status. By clicking on the plus sign on the right side of each station, it will open up to show more information on each bin in that specific station. You can also use the drop-down menu on the left side to pick a specific floor. Here we pick the first floor. We see that station 100L East Exit outside of Market has an alert to change a low IR sensor battery in one of the waste bins. Next, we need to physically go change out this battery. The IR sensor, which is the infrared sensor, is positioned near the opening of each bin. This sensor is used to measure the volume of the contents inside. Each sensor has its own unique MAC ID address, which helps us verify which sensor needs new batteries. Each IR sensor requires one 3-volt lithium coin battery.
We would also receive alerts for low batteries for the weight sensors in the Resource Center. Here we select the 3rd floor and we can see that station 300E near stairwell needs new batteries for the mixed weight sensor. The weight sensors are located at the bottom of each bin, and these sensors measure the weight of the contents inside those bins. Similar to the IR sensors, each weight sensor has its own unique MAC ID address. These sensors require 2 3-volt lithium coin batteries each. To avoid or fix the alert of a negative weight value, we would make sure the plastic bin was placed evenly on top of the weight sensor. Otherwise, the weight sensor would record a negative value due to the bin's incorrect positioning.
We also see that station 300E near stairwell has a low hub battery life. Each station has one hub sensor that is attached to the front of one of the bins. Similar to the IR and weight sensors, the hub sensors have their own unique MAC ID address. This sensor collects the data recorded from all of the IR and weight sensors at that specific station. Then the hub sensor transmits that information to the Resource Center, where we can view and analyze the data. Each hub requires 6 AA batteries. When changing out the batteries, the LED lights light up the tree so we know the hub is functioning correctly. Additionally, we see the alert for the 300E station stating that the IR percentage doesn't match the weight. To fix this issue, we would flatten the bag against the sides of the bin so that the IR sensor was able to scan the entire volume of the container. Now that you've seen how the system works on the ground, we can show you how we get our analytics and data. So we'll start by making sure we're on all divisions. We want to see the data from the whole building. We're going to go to dashboard. And all divisions can also be changed to specific floors, but for this, we're going to just show the whole building. And then so we're on business, and we can scroll down. And the first graph we're going to look at is diversion rate. Looks a little messy right now, so we're going to change our time interval to weekly. And then you can see you can change the time span of the day. We're going to keep it at all day, and date span as well, which we're going to keep it right here. So during around week 25, you see it got very low, and that makes sense because we were on spring break then. And then throughout the semester, you can see kind of how it goes up and down, and usually with higher numbers for our diversion rate, which is a good thing, because you can see here, when you click on this icon, it'll explain what diversion rate is, which it expresses how much material is diverted from the landfill. This statistic is one of the primary KPIs, the key performance indicator for measuring the success of our current program. Basically, the diversion rate is taking your waste and minusing out what you're recycling.
We also found the waste and recycling generation by division and station graphs to be very helpful. In the center, you can see the percentages of the entire floor, and you can hover over the outer edges to see the percentages of each individual station at each floor. And by clicking on the eye icon, it comes up with this little blurb about this chart represents how much waste and recycling is being generated in each division and the station within those divisions. And we found this to be very helpful because it was a great comparative overview of all the stations, so we could see which ones were generating the most amount of trash and the most amount of recycling. That helped us determine where we could add or remove a bin, possibly.
Thanks for watching!